For decades, humanity has been driven by the idea of finding signs of extraterrestrial life in distant galaxies, in other star systems, on the planets of our own solar system. So far, our search hasn't succeeded, but what if we've been looking in the wrong place? What if, before the first human appeared, there was already an advanced civilization on Earth? This might seem incredibly implausible to you, but there are some theories that might make you believe in this version. So what was on Earth before we appeared? And how did this hypothetical civilization influence human life? Hubble. Surely you've heard many stories about how scientists searched for signs of intelligent life, for example, on some planet? However, do you know the answer to the question of how humanity found out that we are the only intelligent beings who have ever lived on Earth? As you know, the Earth is 4.54 billion years old. The first living organisms appeared 3.5 billion years ago. At the same time, humanity has existed for about 200,000 years. That means there's quite a large period of time when we humans were not on Earth, and so many years would have been more than enough for more than one civilization to arise and die out. What if there were once creatures living on Earth that were not like humans, but still had highly advanced technologies? And we can't find any evidence of this because the legacy of that civilization was destroyed by changes in the landscape. However, now we will touch upon the so-called Silurian hypothesis. According to it, once on Earth, specifically in the Silurian period, 443 to 419 million years ago, there lived highly developed reptilian humanoids. Then, as the climate conditions on Earth began to change, these reptiles simply went into hibernation, and these creatures might wake up to appear in a world where humans are now in charge of everything. It may sound like nonsense, but the interesting part is the theorizing about the search for intelligent life. This hypothesis is very interesting because it shows how modern science is capable of searching for a civilization that existed on Earth billions of years before us. It's important to keep in mind that modern methods don't allow us to detect anything significant. Because if these reptiloids do exist, which we highly doubt, they are located deep beneath the Earth. That means our technology can't help us study them yet. In 2018, scientists Gavin Schmidt and Adam Frank actively developed the Silurian hypothesis. They focused on some rather curious phenomena. For example, during the Carboniferous period, that is 350 million years ago, there was already a sufficient amount of fossil carbon, that is, coal. In theory, that would have been enough to sustain the life of an advanced civilization. When studying an exoplanet to determine whether intelligent beings ever lived there, scientists often look at the dynamics of temperature changes, which would indicate climate change. Usually, when a civilization enters the period of industrialization, the temperature on the planet rises. And the interesting thing is that on Earth, 55 million years ago, the temperature increased by 5 degrees Fahrenheit. This is considered a big jump. This period was later called the Paleocene-Eocene. Of course, it's important to remember that such a temperature jump could have happened due to large amounts of carbon emissions, a major volcanic eruption, a meteorite impact, and so on. However, we can't know that for sure. And for us, this is almost the only evidence of the existence of an intelligent civilization before us. After all, the temperature rise could have happened, for example, due to the use of geothermal energy sources, energy that was actively used by a civilization that ended its existence and collapse. If that's true, we have even more reason to believe humanity will vanish the same way. It reminds me of the plot of a typical science fiction novel, where scientists discover the ruins of an ancient civilization and conclude that they became victims of their own progress. It's instructive but detached from real scientific practice, which is forgivable for a work of fiction. Yes, the Silurian hypothesis is simply fascinating, but it doesn't have any irrefutable evidence to support it. And at this stage, it seems unlikely to us that representatives of an ancient, intelligent civilization are currently in hibernation. However, the existence of such a civilization is debated even beyond the Silurian hypothesis. And scientists have some arguments that may support the existence of an ancient terrestrial civilization from the distant past. First of all, it's no secret that several mass extinctions of living creatures have occurred on Earth. To be precise, scientists identify 5 such extinctions. The last such catastrophe happened 65.5 million years ago. This is exactly what killed the dinosaurs. Usually these terrifying events happen relatively quickly. About 75% of our planet's inhabitants died as a result. It is assumed that the civilization of the past simply could not cope with the consequences of the catastrophe and ceased to exist. Its legacy, of course, also disappeared due to climate changes and the movement of tectonic plates. Here you might remind us that we still lack sufficient evidence. And you would be right, because science must be based on a whole system of evidence. Suppose that after an advanced civilization, fragments of their cultural and scientific uniqueness remained. Modern research methods, such as radiocarbon analysis, allow us to determine the age of fossil remains and cultural artifacts. And, of course, humanity has never found anything abnormally ancient and highly developed. There is another pseudoscientific hypothesis of the ancient astronaut. According to it, intelligent extraterrestrial civilizations existed in the universe and may still exist today. They visited Earth and influenced ancient civilizations, including ours. Can you imagine? And which other civilizations besides ours? There are several assumptions. The Maya civilization. Even though they ceased to exist back in the 9th century, the Maya managed to stir up the whole world in 2012. After all, that's when their calendar ended, which caused real panic among future flat earthers and reptilian fans. They saw this as a sign of the end of the world. As you can see, nothing happened. However, it should be noted that the Mayan calendar has a complex calculation system for their era. Add to this the fact that this civilization had advanced knowledge in astronomy and mathematics. How did they acquire such information? Could someone from outside have helped them? No, there was nothing mystical or extraterrestrial about this knowledge. Instead, there was observation of celestial bodies and an interest in the surrounding world. The Indus Valley civilization. Its cities had convenient street layouts, various, let's say, government buildings, as well as drainage systems. The Indus Valley script remains undeciphered. However, we do not know exactly why this civilization disappeared. Ancient Egypt. Not only did the ancient Egyptians invent the technology of mummification for their rulers, which was already very complex in itself, but the Egyptian pyramids have also been the subject of heated debates for decades. How could ancient people build such colossal stone structures? The theory that aliens were involved has long been circulating in popular culture. Ancient Mesopotamia. The Sumerians also had advanced mathematics. They gave us inventions like the wheel and some types of transportation. Their mythology is also interesting. Their deities were called Anunnaki, which can be translated as those who came from the heavens. This gave rise to the theory that the Anunnaki actually existed, only they were not deities, but representatives of an extraterrestrial civilization who visited Earth. Maybe they were the ones who gave the Sumerians this knowledge. Interestingly, other cultures also mention being similar to the Anunnaki. For example, in the Hebrew Bible, there were beings called Nephilim, who were giants. According to the Holy Scripture, these beings were the offspring of fallen angels and earthly women. Actually, there was a rather popular but completely absurd theory that the Anunnaki came to Earth from the planet Nibiru. What evidence supports the idea that these beings are actually ancient astronauts from another planet? Basically nothing except the claims of local lunatics and pseudoscience freaks. It's worth starting with what types of evidence could even exist in this situation. The first thing that comes to mind is fossils. However, that's unlikely since most species never became fossils at all. But don't be disappointed just yet, because scientists managed to find something very interesting. We're talking about the Antikythera mechanism. It was discovered back in the early 20th century on a sunken Roman ship in the Aegean Sea near the Greek island of Antikythera. The ship sank around the 2nd century before Christ. The mechanism was a system of dials and gears that accurately tracked celestial bodies' positions. This way, it was possible to find out how the planets changed their positions, when a solar eclipse would occur, and so on. We still haven't found out who exactly invented such an advanced device for that time, but it is well known that similar, although more primitive devices were already quite common in that era. They were often used by sailors of the ancient world. Undoubtedly, the topic of ancient civilizations, alien teachers, and underground dwellers is very, very fascinating. But despite all the speculation, our channel remains a bastion of science in the dark and superstitious internet. We respect everyone's opinion, but remember that a real fact always needs evidence. What do you want? I want to kill time. Time doesn't really like being killed. This famous dialogue from Alice in Wonderland is familiar to any child, but few people think about its meaning. Actually, Lewis Carroll's book sometimes puzzles even adults, especially when it talks about time. So what does time like? What does it look like, and in what paradigm does it exist? Maybe time is just an illusion, and there is actually no real past or future. These questions trouble both ordinary people and renowned scientists, but no one has found a reasonable answer yet. The encyclopedia says time measures how long objects, events, and processes exist. We can measure length, height, and width with a tape measure or by indirect methods. But how do we measure time? Of course, with a clock. But here's the problem. If you put 2 atomic clocks, one on the floor and one on the table, their readings will be different because gravity affects each clock differently. That means the clock on the table will run faster and the one on the floor will run slower. It's the same with the International Space Station clock, which is the fastest near Earth. And this is just the beginning of a series of many inconsistencies, logical glitches, and time paradoxes. If the measurement of time changes noticeably over such short distances, what can we say about the scale of the universe? And if we don't think about much but simply pay attention to our own brain, after all, it is the brain that produces most of the illusions our consciousness believes in. Dean Bonomano, a well-known neurobiologist, talks about this in his book, The Brain Master of Time, which spans 320 pages. He claims that time is much more difficult to understand than space, and it's hard to argue with that. There are plenty of real-life examples of the subjective stretching or speeding up of time, for instance, when a person in the moment of an accident or disaster seems to see events happening in extreme slow motion. A lot of factors influence our perception of time: body temperature, health condition, and the use of drugs, for example, tetrahydrocannabinol. The latter stretch seconds, minutes, and hours, making them feel eternal. In any case, as long as the cannabinoid acts as a neurotransmitter. But you don't have to join the ranks of pot smokers. The effect of stretching or speeding up time can be induced experimentally by creating certain conditions, or, let's say, by becoming seriously ill. Have you ever heard that fish have a 7-second memory? Let's not offend guppies and angelfish, and instead let's pay attention to some people. At least Clive Wearing. He is a British musician whose memory lasts no more than 30 seconds. The infamous Groundhog Day anxiously smokes on the sidelines. In 1985, the man suffered from encephalitis, as a result of which his brain lost the ability to operate long-term memory. That is, Clive's consciousness resets every 30 seconds, and he doesn't remember what happened before that. Waring is married, and for years every moment feels like the first time for him. If you read the diary of this unfortunate man, it becomes truly frightening, because he crosses out every previous line. He doesn't recall who wrote it or why. His wife published a biography about Clive called Forever Today. Do you think this is an exclusive case where the brain cruelly played a trick on its owner? Of course not. There's a concept called hypermnesia. It's the opposite of amnesia. meaning a person is able to remember every detail of every second of their life, starting from a certain age. Of course, that's better than having to reboot every half a minute, but it's still far from normal. People are prone to many illusions, so why not see time as one of them? What do you think about out-of-body experiences when a person under stress or the influence of substances sees themselves as if from the outside? About phantom pain and amputated limbs. All this suggests that much of what surrounds us and seems real should be questioned, even time itself. What do you think about the past, present, and future? Don't you think that only the present moment is truly real? And everything else is quite relative? But relative to whom? The observer, of course. Let's take the Andromeda paradox, the essence of which is that each observer has their own perception of time. Roger Penrose, a British physicist, voiced this paradox. Here's the idea. One person walks toward the Andromeda galaxy while another walks away. For each of them, events in that galaxy will occur at different points in time. For the one walking toward Andromeda, the events will be ahead of those relevant to the person moving away from the galaxy. On our pygmy scale, this means nothing, but at the distances the universe operates with, all of the above becomes extremely important. After all, for every point in space, there are many simultaneous events, which means that for those two passers-by, their sets will be completely different. Complicated and confusing? You're not the only one who thinks so. The Andromeda paradox has received criticism from many scientists. In particular, it was argued that we shouldn't stretch the concept of the present, which is local, onto global hypersurfaces. And we completely agree with that. What conclusion can we draw from this? Only one. Time is a relative concept and extremely unexplored. If you ask each of us what time is, we will have an intuitive understanding of what it's about. However, it will be difficult to explain this verbally. Why, for example, is time associated with space, calling this conglomerate the space-time continuum? Let's conduct another thought experiment. Imagine an Earthling and an alien with a distance between them of, say, thousands of light years. As long as they don't move, time passes the same for each of them. But as soon as one of them starts moving, their clock slows down. That is, taking into account the enormous distance, if the alien decides to visit Earth, he could end up, for example, in the 18th century, and for him, it would be just as real. Now, do you understand why you can't travel faster than the speed of light? Yes, because it would lead not only to movement through space, but also through time. And then those catastrophic time paradoxes would appear. But let's ease up a bit and give our brains some time to process this information. In the meantime, let's think about this. Why do we always imagine that time moves from left to right? We're talking about the mental timeline. And again, it's all about our brain, which is able to encode the time we're thinking about in a certain way. For most people, this timeline stretches from left to right, but for some it goes forward and the past is behind. You may have noticed that in our thoughts, when we imagine time, it's connected to space. Even common phrases demonstrate this. Looking ahead, winter is coming, summer is behind, looking back, and so on. However, even in the established pattern of mental perception, there are occasional disruptions. Have you heard of neglect syndrome or unilateral spatial neglect? With this condition, the patient ignores stimuli on one side of themselves, and that's just the tip of the iceberg. To understand this, it's enough to read the book by British neurologist Oliver Sacks, with the strange title, The Man Who Mistook His Wife for a Hat. There, it is fully described what a diseased brain can do to our consciousness. This leads to the next question. Is it possible that we perceive the timeline and time itself subjectively? That they are a mental construct with no equivalent in reality? Then why do we need it? After all, nothing in nature exists without a purpose. Most likely, this construct has an adaptive purpose, since it correlates with the physical phenomena surrounding humans. Let's give a very clear example. In reality, there are no smells or shades in our world, but there are molecules and waves that the brain interprets as scents and colors. That's the adaptive meaning of how our brain works in practice. In any case, if we clearly sense the smell of rotten eggs, we're likely to end up in the toxicology department's intensive care unit. But let's get back to the concept of time. What is it? A frozen river? A stable construct still beyond our understanding? Or just an illusion? Cosmologist and theoretical physicist Paul Davies is a supporter of the latter statement. So why are time and space so closely intertwined in our minds? Perhaps our brain automatically spatializes time. So many questions and so few answers. In this context, it's worth mentioning the capo effect, which is a perceptual illusion that occurs when observers judge the time that passes between sensory events. Experimentally, it looks like this. Let's take 3 bulbs, A, B, and C, and place 2 of them, A and C, far apart from each other. The subject will perceive the time that passes between the flashes of bulbs A and C as longer than it actually is. A similar experiment can be done with taps or musical tones. The effect will be the same. One explanation of the phenomenon is that in such cases, the brain subconsciously takes into account the speed and distance between objects, which is why it makes mistakes in measuring time intervals. In fact, the capo effect can be attributed to a broader concept, the perception of time. There is still one more problem to solve. What does the universe look like when time and space are intertwined with each other? Perhaps it's a 4-dimensional block, with one of its edges being time. Our understanding of time was greatly influenced by Einstein's theory of relativity, since it turned out that time is far from being a universal concept and depends on many factors. Thanks to the special theory of relativity, we understand that time on Earth and time at the event horizon of a black hole are completely different things. Have you ever heard the saying that you can't step into the same river twice? It characterizes the linearity of time, its irreversibility. Fallen leaves will never return to the tree, ashes will never become a manuscript again, and the universe will never return to the state it was in a second ago. We also know that a person can only slow down time in their own mind, but not in reality, unless you play this video at a slower speed. However, there are experiments with twins where one of them, having spent time in space, lived a few milliseconds less than his twin. It is believed that if you extrapolate this effect to enormous speeds and distances, the difference could amount to years. For each person, the beginning of time is the day of their birth, and the end is the day of their death. Our planet appeared 4.5 billion years ago. The sun is 5 billion years old, and the universe came into existence almost 14 billion years ago. According to the Big Bang hypothesis, these numbers involve units of time measurement: seconds, minutes, years, centuries, millennia, billions of years. But is there an indivisible ultimate unit of time? It's called the chronon and is used in quantum mechanics calculations. It's a hypothetical quantum whose existence hasn't been proven and is only used in theory. So time as a whole is just like in the joke. I understand that it's half a liter, but I can't prove it mathematically. At the moment, the physics of time cannot answer the following questions. Why does time flow? Why does it flow in one direction? Why is it one-dimensional? Even in the social life of humanity, we observe many faces of time: local time, solar time, universal time by Greenwich, sidereal, astronomical, standard time, and decree time, and so on. Units of time measurement, aside from the unconfirmed chronon, also differ in various areas of life. In geology, there are epochs, eras, and zones. In everyday life, from a yoctosecond to a gigayear, which equals 1 billion years. In music, time is measured by a metronome, and on the internet by bits. 1,000 bits equal 1 day. Many tools for measuring time have been invented: oscillographs, calendars, timers, stopwatches. But none of these help to solve the mystery of time itself. Does it exist if no one is watching it? Is it possible to build a time machine? So far, scientists have concluded that it's not, because experiments have shown that it's impossible to create a space-time continuum where causality is violated. That means debates, research, and discussions will continue at various levels. For us, it will still remain intuitively understandable, even to small children. Science fiction writers will keep improving at describing time paradoxes, inspired by physicists' work. We talk a lot about the colonization of Mars, which could very well happen in the future. We hear about this from scientists as well as in movies, books, and comics. Popular culture doesn't let us forget about it, but what would the colonization of the red planet look like in practice? The path to the exploration of Mars is paved by 5 spacecraft that landed on the surface without a crew and delivered the necessary devices for the functioning of living organisms. Supplies of oxygen, water, dry food, fuel, solar panels, medicines, research equipment, and special capsules where people can live. The ships land in the Erebus Mountains. One of the ships has a Starlink communication system. To establish communication on Mars, you need 4 such satellites. Since the Martian base will be relatively small in size, powerful solar panels, in turn, will provide the base with enough energy. After that, we move directly to the stage of constructing the Martian station. Special dog-like robots from the engineering company Boston Dynamics help with this. Everything is at the service of SpaceX and their grand project. The robots will help lay the foundation of the base and install solar panels, which are a vital source of energy. The first thing the rovers do is start searching for water deposits deep beneath the surface. During the engineering work, they search for the necessary elements in the soil and atmosphere, which can be used to synthesize fuel and oxygen. Rovers and robots level part of the Martian surface to ease the landing process for the first colonists awaiting their turn. At that time, only robots are working on Mars. After 2 years and 2 months, when Mars and Earth are close enough to each other, it's time for the people to fly to the red planet. We'll explain why exactly that much time has to pass a bit later. 30 astronauts are heading there on 5 spacecraft. These are top experts in key colonization fields: scientists, engineers, medical, and military specialists. They also send another fleet of ships with everything necessary for normal functioning on the red planet. The astronauts have to live on Mars for a little over 2 years. It may not seem like much, but they have a difficult mission on their shoulders: to make living on Mars more or less comfortable. And accomplishing this, especially at first, is very difficult because the newcomers have to deal with the effects of low gravity. Add to this the harsh climate with an average temperature of -63 degrees Celsius and frequent dust storms. There are also occasional earthquakes on Mars. What will the daily routine of the first inhabitants of Mars look like? The bad news is that the length of a day there is a bit longer than on Earth. The good news is that moving heavy loads is easier because of the weaker gravity. When the preparations are complete, it's necessary to start producing cryomethane fuel so that there's a way to return to Earth. After all, there are simply no sources of gas or oil on Mars. They don't ignore Martian soils, conducting experiments on them and trying to grow plants. Here, genetic engineering can really come into play. It's worth noting that you can't go to Mars at just any time. The thing is, the red planet and Earth move along their orbits at different speeds. The optimal time for launch comes when the planets are at their closest distance to each other. This occurs every 2 years and 2 months. Spacecraft wait for exactly this moment to bring the astronomers back to Earth. In turn, new people are already flying to Mars, and when there are more people than robotic devices, besides scientist engineers, the crew will include farmers and architects. They are finally completing the construction of a large greenhouse system, so there is more Martian greenery at the base. At the same time, they still have to transport a huge amount of food from Earth. However, Mars is gradually becoming more independent in this area. Artificial Intelligence Space Factory is operating at full capacity. planning to use a 3D printer to build housing for settlers. For this, they use real Martian polymer made from plants grown in the laboratory, and they also add samples of Martian soil. The houses will be designed to prevent radiation from entering. Over time, the quality of 3D printing improves, which makes it possible to create more greenhouses and more devices for growing grain and vegetables. The need to transport agricultural crops from Earth is rapidly decreasing. At first, only the scientific community sends anything to the Martian base, and in most cases, these are research instruments. And it was only a matter of time before world-famous companies wanted to enter the Martian market. For example, Blue Origin, owned by Jeff Bezos, founder of Amazon, is an aerospace company that could arrange private deliveries to Mars. Of course, fish are brought to the red planet and placed in special tanks. We've been talking about new opportunities all this time, but life is also full of sad moments. The residents of the base are not immune to accidents, and even the most ordinary natural death will visit the colonists sooner or later. There will come a time when a funeral will be held on Mars for the first time. The best option is to cremate the body. One of the most important years for the colonists is the year 2035. This is the year of the so-called Great Transition. At that time, the distance between Earth and Mars will be the smallest in history. If previously a spacecraft needed about 7 months to travel from one point to another, now it can be done in 5. The number of settlers increases sharply. The base on Mars can now be considered a city in terms of size, where the first Martian hospital is already being built. Soon, the colony's population reaches 1,000 people. Before that, most of the people were base workers who lived there temporarily. But now, more and more people intend to settle permanently on the red planet. The process of digging underground tunnels as another place to live begins. This is becoming another important area of activity on Mars. Such underground structures are considered some of the safest. In addition, small research stations are appearing all over the planet, farther away from the main base. At first, only robots work there, and then people join them. Mainly, they are engaged in mineral extraction and various research activities there. Different countries build their own bases, establish embassies, and create national symbols. 15 years after colonization began, the first child is born on Mars. Now, Martian doctors have the opportunity to observe how a newborn will develop in such conditions. Of course, they form their own parliament on Mars. Martian policy is aimed at achieving maximum resource independence from Earth, as well as developing tourism. Now, travelers pay a special tax for the development of the red planet. In the Martian hospital, they actively use a bioprinter to print the necessary organs and limbs. Bioprinters are also useful in the restaurant business. With their help, they create bioprinted dishes made from vegetables, fruits, fish, and meat. The first power plants that run on nuclear fusion are appearing on Mars. 46 years later, a settler became the first to climb Olympus Mons. It's not only an extinct volcano, but also the highest point in the solar system, 26,000 meters. Work is also in full swing in Mars orbit. There, they've launched production facilities to process meteorites into useful materials. Then, using those materials, they build critical infrastructure on Mars, like hospitals. In the 56th year of colonization comes the Second Great Transition, which heralds a multiple increase in the population of Mars. Hundreds of thousands of specialists and robotic devices are finally making the red planet completely independent from Earth. The inhabitants of Mars now have their own food, their own energy from solar panels and nuclear fusion power plants, their own air and water. And one of the most important events is that the first person born on Mars is visiting Earth. It's not easy for him to endure Earth's gravity, but a special suit makes it easier. Sounds fantastic. Maybe you're right, and we've just let our imagination run wild. But what if this could actually happen sometime in the future? The amazing thing about our universe is the countless number of galaxies and their clusters. Between the galactic filaments, there are cosmic voids also known as voids. They are enormous in size, so huge that they could contain more than one galaxy. So what exactly are galactic voids? What is our planet in the scale of the galaxy or the entire universe? It's just a small rock that floats along its orbit, revolving around the sun. What is the solar system on the scale of the universe? At the very least, it's bigger than we think. The system has an outer boundary, which supposedly ends beyond the Oort cloud. Beyond that lies an infinite abyss. It seems like there's nothing there. The stars are separated from each other by several light years. This emptiness permeates the Milky Way. It seems to be omnipresent. The void beyond the galaxy is even deeper, even more immense. For example, our system is separated from the Andromeda galaxy by as much as 2.5 million light years. If this space weren't a deep vacuum, it could fit more than 20 galaxies. Some objects are connected by invisible gravitational threads, which we call the local group of galaxies. Andromeda, the Milky Way, Triangulum, and so on. The diameter of such a cluster reaches about 10 million light years. However, the local group of galaxies is not the largest group. There is a much larger one called the local sheet. It has a diameter of 46 million light years and a thickness of 5. The shape of the local sheet is somewhat flattened. Its structure is formed by several hundred galaxies. It belongs to an even larger cosmic object, the Virgo supercluster. However, for now we will focus specifically on the local sheet. Interestingly, its structure seems to form one of the sides of the so-called local void. This is another seemingly endless chasm. Several barely noticeable galactic filaments pass through this void. The void is wide enough to have some connection with the Hercules supercluster. The volume of the local void is gradually increasing due to the gravitational forces of nearby matter and the expansion of the universe. Its diameter is now about 150 million light years. On one side, the void has come quite close to our planet. They are separated by just over 3 light years. You could say that we can observe this void in the starry sky. It covers about 40% of the visible sky. However, in reality, we are unlikely to notice this, since part of the void is covered by the Milky Way, which contains many bright, noticeable objects. We can only see the edges of the local void, which gives us the opportunity to study them. In the 19th century, a small spiral galaxy in the constellation Virgo was discovered, called New General Catalog 6503 over time. It became known as the galaxy at the edge of the universe. Scientists discovered that it is actually located at the center of the local void. Its diameter is about 30,000 light years, and the galaxy is 17 million light years away from Earth. If you look at New General Catalog 6503, you'll notice how bright it is, because there is hot hydrogen in its spiral arms. There are also bluish nebulae around, which contribute to the formation of a huge number of celestial bodies. The brownish cluster is dust and cold gases. Gravitational forces from the Virgo supercluster act on New General Catalog 6503, so it is gradually reducing its distance from Earth, moving at a speed of 43 kilometers per second. As the galaxy approaches us, it will receive more hydrogen, which will contribute to a new round of star formation. Using New General Catalog 6503 as an example, we can trace how voids form in the universe. When the universe was first formed, it also marked the beginning of more large-scale structures. It was a moment when energy and matter were intertwined. The universe underwent many transformations, which over time led to the emergence of low-density regions, voids. Then gravity came into play, making the voids even deeper. Over time, research showed that there were no significant differences in the ages of galaxies formed from cosmic filaments and those that emerged in voids. Mostly, a larger number of galaxies formed 10 to 13 billion years ago. Most likely, the local void will continue to lose its density more and more over time. Because of this, the Virgo supercluster will simply split into several parts that are not connected to each other. We know that the supercluster occupies a space about 200 million light-years in diameter. It contains approximately 30,000 galaxies. You could say that the Virgo supercluster borders two others, the Pavo Indus and the Centaurus superclusters. On the other side is the Taurus void, where there is a minuscule amount of matter. This void is considered one of the largest in the universe. It's difficult for us to study this void because it is obscured by the Milky Way. In this case, infrared radiation helps us. So, we were able to find out that its diameter reaches 200 million light-years. Surprisingly, the void has a rather clear boundary between the area of the void itself and the more distant region with galactic clusters. That's where the Perseus-Pisces supercluster is located. Perhaps such a noticeable separation appeared because of gravitational forces, although for now we can't confirm this theory. Returning to the Taurus void, it's not as simple as it might seem at first glance. It's quite possible that it contains dust and gas clouds, and they could become the foundation for galaxy formation in the future. There's also a theory that there could be huge concentrations of matter or even antimatter there. These are the boldest theories. However, unfortunately, we can't verify any of them yet. Currently, the existence of two galaxies within the Taurus void has been confirmed. Uppsala General Catalog. 2629 is a dwarf elliptical galaxy. The second galaxy, called Uppsala General Catalog 2627, is a spiral galaxy. We are separated from these two galaxies by about 185 million light-years. Meanwhile, the distance between them is only a couple 100,000 light-years. The galaxies are located in the central part of the void. Let's return to the Virgo supercluster. This object, together with the Great Attractor, contributed to the formation of Laniakea. This is another galaxy cluster in which the number of galaxies reaches 100,000. Laniakea stretches for about 500 million light-years. The Great Attractor acts as the gravitational center here. In 2013, scientists discovered that Laniakea is surrounded by a void of enormous size. Voids of such scale had never been observed before. This was such a significant event that it made scientists question the accuracy of some fundamental cosmological principles. Is it possible that the universe is actually far different from what we imagine it to be? It is quite possible that our galaxy is surrounded by a huge supervoid structure. The structure was named Keenan-Brager-Covey, an abbreviation of the scientists who conducted the research: Ryan Keenan, Amy Brager, and Lennox Covey. Its diameter is as much as 2 billion light-years. This discovery helped to solve one paradox. The thing is, when it comes to the expansion of the universe, it's important to determine the so-called Hubble constant. This is a value that shows the rate of expansion of space. However, in the process of calculation, we find that nearby objects are expanding quickly, while distant ones are expanding slowly. Now we know about the existence of the void, which explains a lot. It turns out that the Milky Way and other objects surrounding this void are subjected to additional gravitational influence, which increases the rate of expansion. Keenan-Brager-Covey is still well below the limit. It turns out that this is a part of the observable universe, where there are many more such void spots. They are not smaller in size than Keenan-Brager-Covey. All these dark spots are completely different in their characteristics. Some can be easily explained by basic cosmological principles, while others do not fit into the coherent picture of the universe. One of the most famous examples is the Eridanus cluster, with a diameter of up to 1 billion light-years. This makes the cluster one of the largest objects. This object can only be observed using the microwave spectrum. Thus, relic radiation was discovered, which is 70 microkelvins colder than in the rest of the visible universe. Such a deviation from the average value can be considered the largest anomaly. This object should be studied even more thoroughly, which is quite difficult due to its size. There are still too many mysteries in the universe for us. We pay so much attention to nebulae, stars, galaxies, and galactic clusters, but we undeservedly overlook the voids. They seem insignificant, boring, but in reality, there are so many mysteries and dangers in them. We don't know what else awaits us there. It's one of the mysteries of the universe. And what do you think? Will we ever be able to solve it? Look at the screenshots on the screen. These are YouTube statistics. What do they mean? Currently, 57% of this channel's viewers watch without subscribing. This is the true essence of my message to you. So, in order not to miss out on Hubble among your subscriptions, all you need to do is click on this red button that looks like this and is located below this video. Remember, the universe's law is simple, and your subscription matters to me. The more viewers there are, the more often they watch and hit the like button, the faster a new mega exciting video comes out. Talk to you soon.